So again, now we understand how to graph polynomial functions as long as they are given to us in a factor form. At least if they are quadratic, we know completely, and we know also rational functions. Okay. So now, another question is given a non-linear function, like let's say a polynomial or rational function. Those are the ones that we're going to focus on. We would like to know when they are positive and when they are negative. In other words, when are they above the x-axis, when are they below the x-axis? And the idea is that ultimately we want to be able to answer the question without having to rely on a picture. Okay, so that's what we call nonlinear inequalities. Anyways, let's discuss this. So we begin with an example, and because because we haven't discussed how to do this, we're gonna do it the naive way, which is okay. Let's graph, then we'll look at the picture and understand that positive means above the x-axis, negative means below the x-axis, and hopefully we're going to gain some insight from it that is going to allow us to discover those solutions without having to actually graph. And it will tell you the general way to solve nonlinear inequalities. So as a plan. Okay, so let me start with an example. Let's see, consider the function f of x, and let's say this is 2x times x minus 2 squared times x plus 1, okay? And then let's try to solve the following. I want to know when f of x is greater than 0, and I also want to know when f of x is less than or equal to 0, okay? So if you want, really, what we're trying to solve is this inequality. Okay, so we're trying to solve this inequality. That would be, I guess, the part A, and then part B is this inequality. Okay, the point is that the way that you deal with this is completely different than with the way that we normally deal with linear inequalities. In linear inequalities, what do? We just move things around, solve for x, and then we're able to see what the answer is. Now, these are non-linear inequalities. Here, actually moving things around is not really that straightforward anymore. Okay? Because if you multiply all of these, you're going to get a polynomial of degree. What's the degree of this polynomial? What's the degree here? This degree 4. Okay? And then you will not be able to isolate x. Okay? And then do the same thing that you do for linear. So, there has to be another way to deal with situations like this. So, there are basically two ways to answer equations like this. One way is graphically, okay, and the other way is algebraically. We want to work towards the algebraic way because we don't really want to rely on the graph to answer a question like this, because graphing takes effort and takes time, okay? But then, of course, if you graph, you will be able to answer. Our job is to be able to answer this question without having to graph and just by looking at this. So we're going to do that, but after we do it by graphing, because we first need to get some insight on how we can figure this out without the graph. So, idea, right now what we can do is, we can answer this by graphing. Since we have the following. If I ask you f of x greater than 0, what does this really mean? Can anybody tell me? What does this mean? Geometrically, what does this mean? Very good. So if you have a picture of the function, then you can answer this question because this means when is f above the x-axis. Do you understand this? Remember, f of x is y. So graphically, this means that f of x greater than 0 means its graph is above the x-axis. And then similarly, if we say less than or equal than 0, what does this mean? Very good. It means that its graph is at or below the x-axis. Right? At the x-axis, that will be the equal to 0 part, and below the x-axis will be the less than 0 part. Does that make sense? The point is, if you have a picture, then you can easily answer this question. So let's do that, and then let's revisit the idea, and then hopefully we will get some intuition on how to do it without the picture. Okay, so let's graph. This is the graphing method. Okay, so we have the function f of x, which is 2x times x minus 2 squared times x plus 1. Now, this is a polynomial. I already gave it to you factor. So, you know that to be able to graph this, all you need is the leading term to figure out end behavior, and then the zeros and the multiplicity. That's all we need. Yes?
Couldn't you figure out when it's above x and when it's below the x-axis rather easily? Because in the factored form there, you have the x-intercepts. And you also have the end behavior because you know whether or not it's
Yes.
negative or minus, so you could just assume that.
Exactly.
So,
That's what we're gonna do. The thing is that not everybody knows that, right? Like, where did that knowledge come from? Because you observe at the picture and then you say, wait a minute, I don't really need the picture. The information that's really needed to answer this question, as you just said, is actually already here. And behavior and zeros. That's really all you need. And multiplicity. But again, we need to get there, right? Good. So again, let's do this naively, okay? So let's just graph. And by the way, this way we also, practice the graphing part and review this. So let's see. First, let's figure out. Let's put the zeros. So what are the zeros? What are the zeros? Yes. What are they? 0 to -1, right? So we need to go through 0, we need to go through 2, and we need to go through -1. Okay, so we need to go, these are the zeros of this function. Now let's see, what's the behavior? That's the next thing. So we need the leading term. What's the leading term? What is it? 2x to the 4, good. 2x to the 4 plus lower degree, guys. So what does that mean? That to the right and to the left, we're going up to positive infinity, right? Because that's the end behavior. So we come from here and we finish up here, okay? So now we graph. When we go to -1, we're going to cross because multiplicity is 1. At 0, we're going to cross because multiplicity is 1. And then at 2, we're going to touch because multiplicity is 2, okay? So the graph will look something like this. You need to turn, cross, and touch, bounce back up. Something like that. This is just a rough sketch, okay? So remember, we just want to know when it's above or below the x-axis. So there's no need to plot a bunch of points, nothing like that. This is good enough. Do you understand this so far? So now the point is that you look at the picture and the entire answer, whatever you want to know is already here in the picture. So let's see. We want to know when the function is greater than 0. So we want to solve this inequality. Okay, let's write down the solution. What's the solution? When is this greater than 0? Yes?
When it's less than -1 and after x is greater than 0.
So, and then, between, so there are 3 intervals. Do you see that? So, above the x-axis, that would be here. Yes? Then here, then here. In other words, what would be a solution? Negative infinity to -1, parentheses, because I don't care, equal to 0. It's greater than 0. Union, what's the other one?
-1, 0.
No. We are solving greater than 0. Look at the shaded region. 0 to 2, and then union 2 to infinity. Do you understand this? And then we can also answer the other one. So we want to know when it's less than or equal than 0. So what's the solution? So that would be from -1 to 0, but this time we put brackets because we want to know when it's equal to 0 as well.
And union 2.
Union 2, very good. Union, the number 2, because that's equal to 0 too. Good. All right. Questions? Do you understand this? Now, the point is that we would like to, kind of, okay, let me do one more example, and then we're gonna revisit both, and then we're gonna see all the details. Okay, so let's do another example. This time, let's do it with a rational function. So let's see, let's do x plus 1 over x plus 3, and let's say that I want to know when f of x is greater than or equal to 0. Okay? So again, let's practice graphing the function first. So let's graph the function, and then we're going to answer the question rather easy. Let's see, this one is it's pretty simple, so we can graph it quickly. Let's see, do we have any vertical asymptote? X equals -3. So here is -3, so we're going to have a vertical asymptote there. Do we have any horizontal asymptote? Y equals 1. So here is 1. We have a horizontal asymptote there. Yes? Now, do we have any y-intercept? That's 1/3, right? When x is 0, it's 1/3. So it's going to go through this point, 1/3. And then x-intercept, do we have any x-intercept? -1, right? So here is -1. So it's going to go to this point. So now, the moment that we have this behavior, for example, we can already see that when you get close to -3 from the right, it's going to go down here. And you can think about it. Let's say if you pick -2, we're going to have a negative on top and a positive in the bottom, so that's a negative. Okay? And then when you are to the right, let's say -4, that's going to be a negative on top, a negative in the bottom, that's a positive. So we do this. Okay? And then similarly, the horizontal asymptote, notice that this will never cross the line y equals 1. Why? The only way that this can be equal to 1 is if the top is equal to the bottom. But this top is always 2 less than the bottom. Okay, so they will never be equal. So we have to have stay above here, and here we're going to stay below. Okay? So moral of the story, you can quickly sketch a picture, something like this. And then something like this. Okay, so it's just a quick sketch. If you want, you can follow all the little steps that we did earlier today. But here, I just want to get a sense of what the graph is so that we can answer the inequality question. So now, once again, we look at the picture and then we answer. Okay, we want to know when f of x is greater than or equal to 0. So geometrically, what do we need to look at? Above or below the x-axis? Huh? Above the x-axis. Do we care about what happens at the x-axis? Yes. So this means that we want to know what happens above the x-axis and also at the x-axis. So, what would be a solution? Anybody?
-3 parentheses.
Yes.
Union bracket -1.
Very good. Right? Because we have this portion over here is entirely above the x-axis, so from -3 to -3, it has to be part of the solution. Do you understand this? And then here we are below, okay, so, but then starting at -1, we are at the x-axis, and then after that, we are always above. So, we pick that as well. Does that make sense? Okay, now, of course, we don't want to graph so that then we can ask the question. So, the question is, do we really have everything we need on the formula to be able to obtain this answer without having to rely on the picture, okay? And like your classmate suggested, yes, we do. So let's see what information that is. For example, in the case of the polynomial, okay? In the case of the polynomial, notice that by looking at this, you already know the zeros, okay? Now, this means that any time that we're going to either cross or touch the x-axis, it's going to happen at these points. At any other point, whether it's above or below the x-axis, okay? So the question is, which one is it? How do you know that? Well, polynomial functions, remember, they are continuous. They don't have holes. You can leave your pencil. Everything is nice. So that means that, for example, what's the farthest zero that we have? It's a -1, right? So to the left of 0, the function has to stay in the same place. It's either always on top or always in the bottom. Because otherwise, there will be another 0. If there's a change in sign, it will have to go to the x-axis, creating another 0, which is impossible because we already have the smallest one. Do you understand this? So the easy thing to do is, okay, I know that to the left of -1 is going to be either on top or on the bottom. So what do? Just determine the sign by picking a point and flowing in. Or you can use the end behavior. But if you don't want to even bother about the end behavior, just pick a point. like -2. You plug it in, you get a positive, you know your function is always positive over here. Okay? And the same idea applies to every little interval between the intercepts. Okay? Between -1 and 0, there is no more intercept. So the function has to keep the same sign. It's either always positive or always negative. Because if it changes the sign, what's going to happen? It creates another x-intercept. Okay? So how do you know? Well, pick a point here, plug it in. If you get negative, you know it's going to be below. If you get positive, you know it's above. Does that make sense? You're going to see that now, and now here you keep on doing the same thing. For the case of polynomials, you can do this a little bit faster because you can use multiplicities. So you have your zeros, you put them in a line, the zeros are going to split the line into pieces. 1 piece, 2 piece, 3 piece, 4th piece. Okay? And then all you want to know is figure out what's the sign of the function in each of the pieces. Okay, you can use the end behavior to know how you begin the graph. Because it goes to positive infinity, you know you come from positive. So you start with a positive. And then you use multiplicity. What's the multiplicity of -1? 1. So what does that mean? Is it a cross or a touch point? If you cross, what happens to the sign of the function? It changes, right? It's positive, then it's negative. 0. What's the multiplicity? 1. So it's cross point. So negative, then it's positive. Okay? And 2, what's the multiplicity? 2. It's a touch point, so it keeps the same sign because it touches. So it's positive, then it's positive. And that way you can quickly get it. But if you don't want to worry about that, then all you have to do is pick a point and plug in. Pick a point and plug in to record the sign. Okay? That way you don't have to really rely on the picture. Now, let's see, will that work for a rational function? Okay, it's true that here is the 0 of a rational function, -1. And then to the right, notice how it's positive. To the left, notice how it's negative. So you could figure that out. But there is also another point, which is -3, around which the function is also changing sign. To the left of -3, our function is positive. And to the right of -3, our function is negative. You see that? So if you only look at zeros, you're not going to get the full picture. Now, what is -3 when it comes to the function? What's -3? It's a value that makes the function undefined. Okay? So the general strategy is when you have a function, what you need to do is, and you want to solve a nonlinear inequality, or you're wondering when it's positive or when it's negative, what you do is find the zeros of the function. Find the values that make them undefined. Then you put those points in a line. The line will be, we have a bunch of little intervals, then test signs in each of the intervals. Whatever sign the function has in that interval, it will be at that point will be the entire sign in that little piece. And you keep on doing that behavior. Okay? So let me illustrate this. So note algebraically, we can do this. So for the first example, we had so what was it? 2x times x minus 2 squared times x plus 1. Here there are no values that makes it undefined, so all we have are the zeros. So you write down your zeros, which are x equals 0. Let me just write this. 2 and -1. So what you do is you draw a number line, you put the numbers here. Okay? And then notice how the line is split into 4 intervals. Okay? Now, for example, these are zeros, so if you want to do this, right? Just to emphasize that these are points at which the function is equal to 0. So we close dots. And now our job is to figure out the sign of the function in each of these intervals. For polynomials, you can use end behavior coupled with multiplicities, and then you can figure out everything fast. Okay? In general, what you can do is, because if you don't have a polynomial, then the notion of multiplicity is gone. So then what you do is pick a point in each interval and plug it in. If you get a positive, you're going to put a plus here. If you get a negative, you're going to put a minus in here. Okay? So, for example, and so you don't get confused, don't write anything here. So just do it in your mind. For example, you pick a point, let's say -2. Let's go one by one at a time. If I pick a -2, my signs are going to be negative times positive times a negative. Yes? So what's the overall sign of this product? Positive or negative? Positive. So I'm going to put a plus in here. Okay? Go to the next one and repeat. So let's pick a point here. Let's say -0.5. Okay? And repeat. What's the sign of the function? Let's see. That's going to be a negative for the first factor. The second one, notice that it's always positive because the square. And then -0.5 plus 1, that's a positive. Okay, so this overall product is gonna be a negative. And keep on doing the same thing. So a 1, you plug it in, you get positive times positive times positive. And then 3, you plug it in, you get positive times positive times positive. So then this picture here with these pluses and these minuses, what this tells you is the pluses means when the function is positive, and then negative tells you when the function is negative. So what do you want? Greater than 0, pick whatever has a plus. Less than 0, pick whatever has a minus. Okay? And then you include these guys, whether you include these guys or not, it really depends on the problem that you're asked, that you're solving. If it's a strict inequality, you don't include the zeros. If it's greater than or equal to, then you include them, that kind of stuff. So remember, this tells you here, f is positive, f is negative, f is positive, and f is positive. So if you want to know when f of x is greater than 0, okay, so then that would be, this together with this, and then I guess I should do open circles this time because I'm solving this, right? And it will be this together with this. And then, you get your answer in infinity to -1, union 0 to 2, union 2 to infinity. If you wanted to know less than 0, okay, then it's just this piece here. And so, do you understand this? And then similarly, in the case of a rational function, the only detail is that it's not just the zeros, you also have to look at the values and make it undefined. In the case of rational function, it's the zeros at the bottom. So, moral of the story, if it comes to a rational function, what you do is you find the zeros at the top, which is a -1. You find the zeros at the bottom, which is a -3. That's what makes it undefined, okay? Put those numbers in a line. And let's say that we wanted to know when f of x is greater than or equal than 0, okay? Now remember, zeros at the bottom are never part of the domain, so they always have an open circle regardless. I'm not sure why I put -3 there. Okay, and then 0 at the top is -1, and because I'm interested in greater than or equal than 0, then this time I include it. And now we test for sign. The same story. The line is split into 3 intervals. Just pick a point and test. For example, if we pick -4, there's going to be a negative on top and a negative in the bottom. Negative divided by negative, that's a positive. Okay? You pick a -2, which is on the other side, that's going to be a negative on top, a positive in the bottom, that's a negative. And then, I don't know, pick 0, it's going to be positive on top, positive in the bottom. So what do you want? Greater than or equal than 0? Okay, so this guy. Whatever has a plus. Okay? So the solution will be -infinity to -3, parentheses, union, -1 to infinity with a bracket because of the closure. So it's actually pretty straightforward, okay? So what's the general strategy when you want to deal with nonlinear inequalities? Find the zeros, the values that make them undefined. Put them in a line, there are a bunch of little pieces, test the sign of the function in each piece, and then you pick what you need. If you want greater than 0, pick the pluses. If you want less than 0, pick the negatives. Does that make sense? Okay, so let's see. Do I need to write that down in general, or you understood that? It's okay if we just do examples? Yes? Okay. So let's do examples. When the function is a polynomial, we call it a polynomial inequality. When a function is a rational function, we call it a rational inequality. Okay? So, for polynomial inequalities, you don't have to worry about that step of values that makes it undefined because they are defined everywhere. Okay? But for rational functions, you do need to worry about it. But this idea works for any function. So, for example, if you're going to take calculus later, there will be functions that you will need to know when they are positive or negative, and they are going to be more complicated than just polynomials or rational functions. This is what you do, okay, to test for sign for this type of functions. Okay, So do this. So polynomial inequalities, we'll solve the inequality, and then let's do x squared minus 3x greater than 0, and then let's do x minus 3 squared times 2 minus x less than or equal than 0. That's it. I'm going to give you some time to work on this. For example, just to give you a little peek, this is very important. And for example, my calculus student, they actually didn't know how to do these things. I don't know why. This is just to show you we are almost at the end in that class, and what we do is we graph functions, any function in this case, and you see here I'm doing inequalities. Here is a picture for the sign of the function, then you look at what we call the derivative, and again you do the same thing. You want to know the sign of the derivative because that tells you something about whether the function is going up or down and whether you're going to have maximum or minimums. Then you look at the second derivative, and once again you want to know the sign of the second derivative because that tells you the concavity of the function, whether it looks like an x squared or a negative x squared. Okay, so all that information is encoded in the sign of those functions, and most of the time what you're dealing with is with nonlinear inequalities, functions that are not linear. Okay, so you do exactly what we are discussing right now. So you will be using these techniques later on. Anyways, just remember, for polynomials, it's just zeros, put them in a line, and then you can do it quickly. If you want to use n behavioral multiplicity, it would take you a bit more time if you pick points, but the picking point part is the one that always works, regardless of the function. So let's see, for this problem, what do you think is the first step? What should be the first step? So the first thing is that you need to move everything to one side and have 0 on the other. That's the first thing, because you want to change the equation to something above or below the x-axis. Right now here I don't have to do anything, but if the question would have been like this, okay, your first step would have been to move the 3x over, okay? Then you have to factor. Why do you want to factor? Because when you factor, it's really easy to find the zeros, okay? And if you have a rational function, you need to factor both top and bottom. Okay, so let's see. Let's do this. So again, I'm gonna factor. So take out an x. So now we can easily write down the zeros. Okay, so what are the zeros? So 0 and 3. So now we're gonna put them in a line, right? So we draw a number line with the numbers that you found, 0 and 3. And now you need to ask yourself, do we want this to be part of our solution? Are 0 and 3 part of our solution? Why? Because it says greater than 0. Good. Therefore, we're going to do open circle. Okay? This way, you don't make a mistake of including this. Now, our job is to determine the sign of the function on each of these pieces. Okay? So, you can do that. I'm going to show you. So, let's pick point and plot, but then I'm going to show you how to do it with the behavioral multiplicity. Anyways, so pick a point here, let's say -1. Remember, you don't really need to plug in the whole thing, just a sign analysis. So it will be a negative times a negative. So I give you a positive. Do you understand this? So just plug into the factor ratio, that's easy. You put -1 here, that's negative times negative. Okay? They give you positive. So now pick a point in the next one. Let's say 1. Okay, so it will be positive times negative. So that's a negative. And then in the next one, let's say 4, that would be positive times positive. So that's a positive. Now the next question is, this is the sign of a function. Right here we have the sign of a function in this little picture. Now, what do we want? Do we want process or do we want minuses? What do we want? We want the process because it says greater than 0. Hopefully when you see greater than 0, you think about plus. And if you see less than 0, you should think about minus. Do you understand this? Because it says greater than 0, then that tells me that I want this and this, whatever has a plus. Okay? So the moment that you draw this picture, then it's really easy now to give the solution. So what's the solution? Negative into 0, parenthesis, union, parenthesis 3, comma, infinity. All right, questions? Okay, so how about the next one? So we have x minus 3 squared times 2 minus x. Let's see here, it's already factored for us. What are the zeros?
2 and 3.
So the zeros are 2 and 3. Let's put them in a line. Let's see, I'm going to do this one with multiplicity. Okay? Again, you can do it by picking points, but let's change it a little bit and let's do it with multiplicity. Now, do we want 2 and 3 to be part of the solution? Yes, we do, because it says less than or equal to 0. So, to stress that, let's use closed circles. Okay? Now, our job is to put pluses and minuses in here. Okay? Again, you can do it by just picking points and plugging. I'm going to do it slightly different now, so you see another approach. Okay, so let's use the behavior of the function to know where to begin. Do we begin with a positive or with a negative? So let's see, here you can, if you want, you look for the leading term. But here, because this is too small, you can actually do it very quickly. This is always positive, right? Because the square. And when x is very negative, this is this actually is positive because the minus x. Do you understand this? Or if you want, just to make it easy, just pick a point for the first one at least. Let's say 0. You put it here, that's positive times positive. Okay? Now, you know the first guy. Once you know the first sign, then the rest you can get it by multiplicity. For example, we hit this 0. That's a 2. What's the multiplicity of this guy? 1. What does that mean? Is it a touch or a cross? It's a cross. So what should be the sign on the next one? Minus. Do you understand this? Because it's crossing. Now we hit 3. What's the multiplicity? So what does that mean? It's a touch. Therefore, the sign stays the same. So you get a negative. So the sign will be plus, minus, minus. If you think about the graph is doing this. This is what the graph is doing. Okay? It's coming from up here, it's crossing, it's touching, and coming back down. Okay? That's what it's doing. Of course, you can just pick points and plug in, and you're gonna get this. Okay? For example, if I pick 2.5, it's still positive, and then this one was gonna be, if I put 2.5, that's a negative. So positive is negative is negative. And here let's pick a 4, positive, and then I put a 4 here, 2 minus 4, that's a negative. So positive and negative is negative. Okay? So you can do it by picking points if you want. Anyways, now the question is, what do we want? The plus or the minus? We want the minus. Why? Because it says less than 0. So that means we want this and this. Now here, there's really no need to skip to write this as 2 intervals because anyways 3 is included, so there is no gap. There's no break in the interval. So this is just greater than or equal to 2. Do you understand this? You can do 2 to 3, union 3 to infinity, but you put in brackets, so might as well just write 2 to infinity. Okay? So the solution then is bracket 2 comma infinity. Okay, questions about polynomial inequalities? It should be pretty straightforward. Just find the zeros. If you can find the zeros, then that's it. Put them in a line and test. Okay, and then you decide what you want, the positive or the negative. Are we good? Okay, so then now let's do it with rationals. Now rationals, sometimes the algebra is the one that could be, in the way. Show you our last two examples. They will be slightly more interesting than the first three that we're gonna do. Anyways, solve the inequality. Remember that when it comes to rational inequalities, you also have to worry about the zeros at the bottom, not just zeros at the top, okay? Which are the values that makes it undefined. Solve the inequality. Let's see, let's do x plus 2 over x minus 3, less than or equal than 0. Then let's do 5 over x squared minus 4, greater than or equal than 0. Let's do a square less than or equal than 4. Let's ask when 1 over x is bigger than 1. And then let's compare two rational functions. Let's compare 2 over x minus 1 versus 4 over x plus 1. Okay. So remember, the first step is always to have 0 on one side. Okay. So for problems 1 and 2, we already have 0 on one side, so that's okay. But now for problems 3, 4, and 5, you need to move everything to one side first. Okay. And combine. So that will be, I guess, the problem. That could introduce some complication when you want to combine. Make sure that you do it carefully, you find the LCD correctly, and all that. Anyways, we get to that in 4. So let me illustrate for number 1, and then I'm gonna give you some time to do number 2. So again, wanna do x plus 2 over x minus 3 less than or equal than 0. First step is to factor everything. There is nothing to factor. We already defined as it is. So we immediately can write zeros on top and the zeros at the bottom. Okay, what are the zeros at the top? Negative 2. Bottom? 3. Did we do this? Looks very similar to something. All right, so now we put these numbers in a line. Okay. So negative 2, 3. Now, we need to ask ourselves whether we want to include some of these points or not. Now, regardless of the situation, the 0 at the bottom is never included. Okay, because this is what makes the function undefined. So you automatically put an open circle around the 0 of the bottom so you don't get confused. Now the question is, should we include the negative 2 or not? Okay, so negative 2 is the 0 of the top, so that's what makes the function equal to 0. In this case, we want to be less than or equal to 0. So in this case, yes, we want to have negative 2 as part of the solution. Do you understand this? So we do a closed circle here. If it would have been less than 0, I would leave it open. Okay, because we wouldn't want that. Now again, 3 intervals with test for signs. Pick points, plug in, etc. So let's see, let's pick negative 3. What's the sign of the top, positive or negative? If we pick negative 3. Is the top positive or negative? We have a negative, and then the bottom is also a negative. So negative divided by negative is a positive. Okay? Go to the next one and repeat. I don't know, 0. So that's positive on top, negative in the bottom. So that's a negative. Now go to the next one and repeat. 4, positive, positive. That's a plus. Okay? So now the question is, what do we want? Do we want the plus or the minus? We want the minus because it says less than or equal to 0. Do you understand this? Is it clear that less than 0 means minus? Yes? Okay. So then, that's what we pick. So solution, we bracket negative 2, 3 parentheses. So on that interval, that function is below the x-axis. On the others, it's above. Questions? All right, so go ahead and do number 2. Do 2 and 3 in 10-minute solutions that you get. I'm going to give you 5 minutes to do those. So number 2 is 5 over x squared minus 4. And then 3 is x squared less than or equal to 4. So do these 2. For example, if you're going to graph a rational function, even though we're doing this after we discuss the graph, this is actually a good thing to do before you graph. Because it's pretty easy to do. And if you do this before you graph this function, for example, you immediately know that here we have a vertical asymptote, because it's positive, you immediately know that the behavior is up to the right and down to the left. You see what I'm saying? So this is very helpful to do it if you're going to graph. And then that way, when you do your picture, you already know what to expect. Above the x-axis, below, above the x-axis. Okay? So, even though it's not really required, anyway, that's what you do. What do you do to determine whether it goes up or down around the asymptote? You plot the point, and then you see if you get a positive or a negative, right? That's exactly what we're doing here. So, I will add this as an extra step. I didn't add it before because we didn't know this. But now that we do, you should do this before you draw the graph to be, to make it easier to sketch the graph. It really helps. Okay, anybody has an answer for this one? For number 2? No. The inequality, solution to the inequality. I'm asking you to solve this. So I want to know when this is greater than or equal than 0. So your answer has to be an interval notation. Yes? What is it? So say it louder. To what? To negative 2? To 2. Like this? Okay. Interesting. I mean, maybe I'm not saying wrong. I was expecting something different. Yes? This one? Like that? Okay. All right. Anybody else have something different? Yes? You mean everything except 2 and negative 2?
Yeah. Wait. No.
You're giving me the domain. So remember, here we are asking greater than or equal than 0. Yes?
I got bracket 2, infinity.
Like that?
Yeah.
Okay. Be careful. 2 function is undefined. Remember, zeros at the bottom are never included. So you should not have a bracket around 2. Okay? Zeros at the bottom are never included. Okay, let's see. So let's do it. So what's the first thing that we should do for this problem? What's the first thing that needs to be done? You factor everything, right? So let's see. Let me put this one here. Okay, so let's factor everything. So it will be x plus 2, x minus 2. Right? Next, we find the zeros at the top and zeros at the bottom. Let's see. What do we have zeros in the top? No zeros in the top, right? So nothing coming from the top. Okay, that's fine. Do we have zeros in the bottom? What are they? Negative 2 and 2. So once we have this list, we make our line. Now, the zeros at the top, they are never included. So automatically when we do this, we put open circle. Okay, for the zeros at the top. Now, you need to wonder whether you should include, zeros at the bottom. You should wonder whether you should include the zeros at the top or not. In this case, there is not even a zero at the top, so we don't even consider that. Okay? So, but zeros at the bottom, they are never included because the function is not defined. That's why you put open circle. So even if it says greater than or equal to 0, this is irrelevant. This function is never equal to 0 because there are no zeros at the top. Okay? So we're gonna have parentheses all the time. Now, let's pick points and test. Let's see. You tell me, what number should I pick? Left to right? Negative 3. Okay, so tell me the sign of the function at negative 3. And there are 3 components. Top, first factor in the bottom, second factor in the bottom. Okay? So, positive. Okay. Negative and negative, right? So what's the overall sign? Positive. Does everybody understand this? Let's go to the next one and repeat. Tell me a number. Negative 1, okay? So tell me the signs. Tell me the signs on each of the pieces. This is fast, it's quickly. Positive, then positive, and then negative. Does everybody understand this? You just put a negative 1 in here. The top is always positive. This one is positive, this one is negative. Okay? It really requires almost nothing. Okay? Now you look at this and you say, and you will figure out what's the overall sign on this expression, positive or negative? That's a negative. Okay. Tell me a number for the other one. 3. So what's the sign? Does everybody understand this? So what's the overall sign? A positive. So now that we have this picture, we look at it and we decide what do we want, plus or minus? We want the pluses. Why? Because it says greater than or equal to 0. So take this guy and we take this guy. Do you understand this? So this is the solution. Okay? Yes.
I don't get how the other solution is on the negative 2 side is right.
You mean this one?
No, plus side.
Oh, because the function is positive then.
Also, it's basically the function of the numbers.
Of course, so we are asking when is this expression positive? And the whole discussion that we have been saying is that you look at the zeros and the values and make them defined, and then that will break the line into a bunch of little pieces. The sign of the function in each piece is always the same. It's either always positive or always negative. How do you know? Pick a point and plug it. So we're picking a point here, let's say negative 3, okay, which is on this part right here, and you put it in here. When you put it, what do we get? The top is positive, this one is going to be a negative, and this one is going to be a negative. Okay? So when you calculate this, what do you get? Negative times negative in the bottom is a positive. And then positive divided by positive is positive. So that means the function is positive on this part. And I want to know when it's positive, so I have to have this as part of my solution. If you only tell me this part right here, you are skipping the other, this other part. that is also okay. All right. Okay. Questions? Okay. So this is our solution. All right. So how about number 3? What's the first thing that we should do? So move the 4 to the other side. Now here we factor. And then we are in business. So we know the zeros, -2 and 2. This time we include, right? Because it's less than or equal to. And then, you just do it as usual. Pick points or use multiplicity, whatever you want. The point is that you're going to have the signs, right? Plus, minus, plus. So what do we want? Pluses or negatives? We want the negatives. So this time, this is what we take. So the solution is -2 to 2 with brackets. Questions? Okay. And then let's see, let's do this one, and then we do the other one. Okay, so here, remember, you need to have 0 on one side. So the first thing that we're going to do is we subtract 1. Make it greater than 0. So now remember, to combine these, you have to make sure that we have the same denominator. So here, what's the denominator on this one? What's the denominator? So the denominator here is 1, right? So instead of a 1, what do we want to have in here? An x. We want the denominators to match. So what do we do to have an x in here? Multiply top and bottom by x. So I multiply the top by x and the bottom by x. So instead of 1, we write x over x. Does everyone understand this? Yes or no? Okay. So when you do that, let me rewrite it. So now we can combine. So we get 1 minus x over x greater than 0. And the moment that you do that, then we have a rational function. We estimate the process. Same thing as before. So we do the zeros of the top and the zeros of the bottom. So let's see, 0 of the top is 1, 0 of the bottom is 0. So 0, 1. We never include 0. In this case, I don't want to include 1 either because it's greater than 0. So we do an open circle, and now we test for signs. So let's see, we pick -1, that's going to be positive or negative. So that's a negative. Then you pick, I don't know, 0.5, so that's going to be positive or positive. And then if we pick 2, that's negative or positive. So that's a negative. It says greater than 0, so I pick the positive. So that means the solution is from 0 to 1. Okay, questions? Yes?
What is it closed or is it open? What is it?
Open means you don't want the point as part of the solution. Closed means you want the point. When you have a rational function, you never want to include the zeros at the bottom because the function is not defined there. So x equals 0 doesn't work for this function. You understand this? So 0 automatically they get an open circle. So 0, which is the 0 of this guy, gets an open circle. Now the question is, should I include 1 or not? Well, if you look at this, what does it say here? Greater than 0. That means I don't want to be equal to 0. I want to be bigger than 0. So 1 is when this equals 0. Because you want to be greater than 0, then you don't include it. If it says greater than or equal to, then you include the 0. So, it depends whether you have this symbol or this one. Or this one or this one. If you have any of these two guys, then you don't include anything. If you have this, then you include the zeros at the top. Okay? Not the bottom. The bottom is never included. But if you have greater than or equal to or less than or equal to, you include the zeros at the top. And as you know, open and close circle means parentheses or bracket, right? Depending on what it is. Okay. Questions? Right, let's do the last one. So then let's do 2 over x minus 1 greater than 4 over x plus 1. By the way, before I do this one, let me just show you the geometric interpretation of what we just found. So, so the geometric interpretation of what we just found in this problem is the following. We know the function 1 over x. So basically what we are asking here is, when is the function 1 over x above the function y equals 1? That's what we're doing. Here we're comparing these two functions. Okay? And our answer was, well, between 0 and 1, this is going to happen. Otherwise, this function is below. And you can see that quickly, because if you graph 1 over x, right, this is how it looks. Yes, as a function 1 over x, y equals 1 over x. And then the function y equals 1 is this one. Yes? Now, notice that this is an important point. So, what is this point right here? This point of intersection? When do these two functions meet? When do they equal to each other? When are these two guys equal to each other? X equal 1, right? So 1, 1. So this is the point 1, 1. Everybody okay with this? Now look at the picture. When is 1 over x above y equals 1? Well, it's right here. Right? Only this picture is when it's above, and that is between 0 and 1. That's what we just figured out there, between 0 and 1. Away from those two is always below. Okay? So for example, now here we have two rational functions. And we are asking, when is this function above this function? Okay? That's geometrically what we're solving here. All right. So let's do it. So again, the first thing is that we need to have a 0 on the other side. So move everything to the left in this case, for example. And now we need to subtract these two. Remember, to subtract, you need to make the denominator the same by looking at the LCD. What's the LCD here? What's the LCD?
X plus 1 times
X minus 1, x plus 1. Good. So we just fix it, right? So go to each of the fractions and then we put whatever we're missing. What are we missing here? To get the LCD? What are we missing in the first one? X plus 1. So we multiply top and bottom by x plus 1. Go to the next one, repeat. What are we missing? X minus 1. So multiply top and bottom by x minus 1. Make sure that you put parentheses appropriately. Okay? So then we're going to have x minus 1 times x plus 1 in the bottom. And then on top, we're going to have 2 times x plus 1 minus 4 times x minus 1. Okay? And now, simplify this. So that's 2x plus 2 minus 4x plus 4 over x minus 1 times x plus 1. And then we get, what is this? Negative 2x plus 6 over x minus 1 times x plus 1 greater than 0. And then you can take out a negative 2 and you will have an x minus 3. Okay, so this is what we obtained, and now we activate the process. So we find the zeros at the top and the zeros at the bottom. Okay, what is the zeros at the top? When is the top 0? At 3. When is the bottom 0? 1, negative 1. So we put these numbers now. Negative 1, 1, and 3. Remember, zeros at the bottom, automatically they are out of the question, so open circles for those. Now we wonder, should we include the zero at the top? Well, let's see. What symbol do we have? It says greater than 0. That's a strict inequality. So that means don't include it. Right? You want to be greater than 0. So nothing gets included. You will include it if it was like this. If it was greater than or equal to 0, then yes, you include the 3. Okay? But it's not. It says greater than 0. So we don't include it. Is that clear? This number is what makes the 0 at the top is what makes this equal to 0. That's when a fraction is 0, when the top is 0. Do you want this to be 0? what does it say here? Greater than 0. It means we don't want it to be 0. Okay? We want it to be positive. So you don't need to do anything. Okay? Now you just pick points and do the same thing. So let's see, -2. And keep in mind that there's a negative here. Okay? So when you put a -2, what are we going to have? A negative here, but with the negative becomes positive. Okay? So positive over negative times negative. Yes? Yes. So that will be a positive. Now let's pick 0. If I put 0, then that will be negative times negative. So that's a positive on top, and then in the bottom, I'm gonna have a negative times a positive. So it's a negative. Then we can pick 2. So as negative times negative, that's a positive on the top. Then in the bottom, we're gonna have positive times positive. So that's a plus. And then, oh wait, hold on. Yes, okay, yes. And then 4, that's gonna be negative times positive, so that's a negative on top. And then down here, we're gonna have a positive times a positive. So that's a negative. So what do we want, pluses or minuses? We want plus, because it says greater than 0. This is very easy, but make sure that you don't get confused. You get confused, you choose the wrong symbol, that's it, you get the problem wrong. Okay, so make sure that you understand this. So again, greater than 0 means plus, so I pick whatever has a plus. Okay. So what's the solution? Yes? Union 1,3 and then parentheses everywhere. Good. And by the way, those are the places at which the function 2 over x minus 1 is above 4 over x plus 1. In the other places, in the minuses, is below. Okay? If you were to grab the two functions and compare them, you will find this relationship.